I got a ton of examples. I'll try not to make this take any longer than it needs to, but today's May 1st. The next time the month changes from month to month, you will have been on summer break for 8 days. So congratulations on that. Yeah, I know, right? And we're officially gonna listen, all we're gonna do now for the rest of the year is work with quadratic expressions and quadratic equations. So today there are no equal signs. We are just factoring quadratic expressions. And this is really important that you know the difference between an expression and an equation. Remember that equations have equal signs. Equations, so when people say, like, if I give them a math problem like 2 plus 2, and they say, you want me to solve that? I'm always like, no, I want you to simplify that. We can only solve things if they have equations in them. So for the next few days, a couple days at least, we're not going to be solving anything. We're going to be factoring quadratic expressions. And then starting on Monday, that's when we start putting our factoring skills to use and start actually solving equations with quadratics. So next 2 days, no equal signs, no solving. Okay, we're factoring. So go ahead, buddy. You do what you got to do. So let's run through some examples. We talked about this in the lead up to the Y-top, so you're pretty familiar with what it is I'm asking you to do. So my goal for this lesson is to try to cover as many possible sort of scenarios as possible. And the idea here, remember, is to factor something means to break it down into two pieces that multiplied to make it. So if I give you a quadratic trinomial like this and ask you to factor it, you remember what we start with is our shells, right? Get used to building shells. And then what are we going to put in the fronts of the shells? We know we need x's here because they have to multiply initially to make x squared. And then the order in which we do these things is really important. Like, don't go rogue and like make up your own stuff here. The next thing you absolutely have to do to be a good factorer is look at only this sign that I've circled in yellow. Look nowhere else. The fact that that's a plus sign means that the two numbers that I put in these two blanks have to multiply eventually at the end. You remember they have to multiply to make a positive number. In math, if you multiply to make a positive, you either have to have two positives or you have to have two negatives. That is not up for debate, right? So we have to now decide, is it two pluses or two minuses? So we now look somewhere else to help us make that decision. Where? The other sign, right? Generally, I don't give a rip about the red sign. The red sign oftentimes will be something that you don't worry about this early in the problem. But when the back one is a plus, we need the red one to tell us what they both are. So the red one tells us, I got you. They're both pluses. And at this point, factoring is really just a trial and error sort of process. You know, this is why I gave you your factor sheet. You all, quite frankly, should know by 9th grade what the factors of 24 are, but that piece of paper can come in handy so you can just see literally all of them listed out. So sometimes I have people write them all out, but you know what they are. So, you know, you could try things like, obviously 4 times 6 makes 24, right? But if I put in 4 and 6, I can grade this myself and figure out that it doesn't work, because if I do purple and green, what's purple make? Right, so purple's 4x and green is 6x. And if you add those, you get 10x. And 10x is not what we're looking for. We're looking for 11x. So factoring is a lot of, at first it feels kind of trial and error, like guessy, and eventually you start to just get quick at it. What number should I have put there? 8 and 3 for sure, right? And the order that you put them in right now, this early in the lesson, doesn't matter. So that's it. You're done. X plus 3 times x plus 8, problem over. You factored. We'll take that and use it for something starting Monday. But for today, we're just stopping there. We did it. Pat yourself on the back. Okay. So let's head on. I got a bunch of these. So always just kind of instinctively get in and build your shells and start by building the front, right? So we know we need a pair of X's for sure. Now, again, the order in which we look at things is the key. I know this is something I can do a better job of, is getting kids to really buy into this. I know we talk a lot as teachers, and kids have a hard time filtering out what's important versus what's just teacher talk. This is important. Look at the number in the back. That is a positive. And if the number in the back is a positive, that in and of itself means the two numbers that I pick have to be the same, right? So then I need more information. I defer to the red guy. And what does he tell me? That we need two negatives. That's the order that those numbers and those signs will communicate to you. You need that communication to happen in that order. Number in the back is first stop, number in the middle, backup plan, second stop. What numbers multiply to make 16 that would work for our purposes? 8 and 2. There you go. And again, you can always check your factoring because you know if you multiply there Mr. Purple and Mr. Green, Mr. Purple makes negative 2x and Mr. Green makes negative 8x. Add those together, presto, you get your negative 10x, right? All right, let's change it up a little bit. Absolutely. Yep, factoring is just literally backwards multiplication. Another word for factoring is basically division, right? So it is a 54. I was worried about that 5. That was a little ugly there. So I'm going to build my shells. I'm going to put my X's, and I'm going to do exactly what my teacher said to do. Step 1, I'm going to look at the number in the back. What does the fact that it's negative mean? They literally have to be one of each. You can't like come in later in the problem and say, well, I'm just going to try making them both minuses. You cannot outwit what is a fact. The fact is that they are going to multiply to make a negative 54. You cannot then fight the fact that there is one positive and one negative. That will not change. It's at this point that I generally don't care about the number in the middle. The one that I've been circling in red, I tend not to with problems like this because I really don't care now. Like I care, but it's not going to change what signs I picked. So at this point, we get in and we start thinking about numbers that make 54. What numbers come to mind? Yeah. And there are other numbers. There's 2 times 27. There's 3 times 18. There are other pairs that make 54, but the one that we want, and you start to just see this instinctively, the pair that we want is definitely 9 and 6. And we know that because if we do Mr. Purple and Mr. Green, what does Mr. Purple make? Positive 9x. And what's Mr. Green make? You add those together and you get what you wanted. You're trying to make that one in the middle. That's what the goal always is. You know, can I make the one in the middle? Making the front is easy. Making x squared is like, duh, bless you. And making negative 54 is also pretty duh, right? So I'm not worried about that's easy. It's making it all harmoniously equal what I want in the middle. That's the challenge. So I'm successful on that one. How about this one? Start with my shells. And I'm going to look at the number in the back. Absolutely. It's not even up for debate, one of each. Some people like to put their negative before their positive, and later on you might just find yourself erasing those. You'll see later in the lesson, sometimes we got to erase them and switch them. If we realize that we got them, it's okay. That's what erasers are for. So we're all set. The stage is set. What numbers come to mind when you think of 42? And again, there are 2 or 3 other pairs of numbers that make 42, but 6 and 7 come into mind because 6 and 7 are 1 away from each other. And the number that we're trying to make in the middle, I'll make it yellow for you. You can clearly see is -1, right? So it's that we're trying to make the numbers kind of play off each other to make the middle. 6 and 7 have a difference of 1. So now I just have to make sure I put them in the right place. Who do I want with the minus? Yeah, you want to put the 7 here and the 6 here. It does matter because I want the dynamic to come out right. When I do Mr. Purple there, that's -7, and I want that to be more powerful than Mr. Green, a +6, so that when I add them, I keep it at -1. Good. Okay, and now there's a couple special cases, and then we're going to get to the harder ones, and then I'll be done. And again, tomorrow, nice big fat full work day. Nothing to it. So, and I may not actually add on another assignment tomorrow, but I might. So I'll be calling audibles on that Algebra 1 schedule thing I gave you. If I have to call some audibles along the way, I don't want to overload you or anything. So you remember these? We talked about these, I think, the day before. What's weird about that? There's no middle term, and I love the fact that you called it that. That's exactly what we need to start calling it. This year, Algebra 2, middle term is our guy. If the middle term's missing, then we know it's one of those situations where we had to make the middle term go bye-bye. And how do we do that? Same number, but different signs, right? That's the only way to make two things like that go away, is to say, well, I need one of you to be something, and I need the other of you to be the opposite of that something. So I know there has to be one plus and one minus because there's a -4, and because I need it to cancel. And what numbers do I need to use? 2 and 2. Okay, that's called a difference of two squares. It'll play a very significant role at some point, but not really this year. All right, here's another difference of squares. You just come to recognize them. They got a look. Just get a look about them. You look at them and go, I know who you are. One of those guys without the middle term. So build your shells. Force that cancellation, right? You're the boss. When you factor, you're the boss. You write the problem. You make it happen. So we need one with a plus and one with a minus. And what magic numbers would we use here? Yeah, and that one's not on your sheet, but you guys should probably all know that 11 and 11 make 120. If you don't, calculators can help you. And the other special case, which really honestly isn't that special, it'll be more special next week, is something like this. And listen, it's a regular factoring problem, quite frankly. And if you just sit there and look at it, you may not notice it right away, but it's actually called a square trinomial. And let's take a look at why. Let's factor it. Just normal, par for the course. Just another Wednesday morning doing our math. When I look at the number in the back, it tells me they're both the same. The number in the middle then tells me that, well, they're both pluses. And what numbers are we thinking of? 7 and 7. I'm trying to multiply to make 49, and 7 and 7 is probably the first thing that would come to mind. Now, this actually works because if you check out purple, you get 7x, and if you check out green, you get another exact identical copy, 7x, and two 7x's put together make 14x. We call this a square trinomial because this is really not how you should be writing this answer. You should be writing it as x plus 7 squared, hence the name square trinomial. Okay, so if you can factor something down and its factors wind up being exactly the same as each other, write it as the thing you got squared. Now let's do one more of those, and then we'll head on to the harder ones. Just becomes sort of a robotic process, by the way. This whole building the shells, placing your beginners, looking at your signs. That's the goal of the next 2 days, is to get that trained into your brain. You know, just gets stuck. You don't think about it anymore. It's like autopilot. The number in the back tells me they're both the same. The number in the middle then tells me that they're both negatives. If you do that in any other order, then you and I are going to have some troubles. Like, it's got to go back number first, the middle number if necessary, but only after that. What are the numbers we're thinking of? And again, it just so happens that this works into a square because it's something times itself. So we would not write the answer like that. We might write the answer like that initially, but then we're going to change it and write it as x minus. So everybody doing fine so far, I assume? Okay. So when this gets a little bit more difficult now is when we place a number in front of x squared. So if I place a number in front of x squared, the dynamic changes. Everything has changed. You get in a mindset of saying, oh, you're telling me I just need to find two numbers that multiply to make 12 and add to make whatever. That only works for those warm-uppy problems where there's no something in front of x squared. If x squared has a visitor in front, then you got to change your thinking. There are no numbers, I assure you, in the known universe that multiply to make 70 and add to make 39. But that doesn't mean we're screwed. Like, we can still do this. So let's build our shells, just like always. But you might remember, I think we talked about this in the review, we can't put x and x, we have to put 7x and x. If you put x and x, that'd be silly. Like, you go, oh, that doesn't work. It doesn't multiply to make 7x squared, right? So let's follow our signs. What does the sign in the back tell me? On the 70? One of each, right? And so at this point, really, this is where the signs really just expect to have to switch them about 50% of the time. It might be plus minus, it might be minus plus. And yes, it will matter. So now we go through and we start thinking about numbers that multiply to make 70. So look at your sheet. But the first pair, you probably don't need a sheet for, I'm guessing. What's the first thing that pops into mind? 7 times 10, right? So we could try 7 and 10, but here's what you have to understand. Placing 7 in the first one and 10 in the second one is completely different from placing 10 in the first one and 7 in the second. 7, this 7 over here, I'll point to him. He really mooks everything up, dudes. He's a bad guy. So you got to bear in mind now that switching numbers is now in play. So which pair would you like to try first? 7, 10 or 10, 7? Say it again. So you want the 10 here and the 7 here? I'll take it. And bear in mind, there's a lot of things that could happen here. There's a lot of possibilities. But it just so happens, and I think Gage probably knew this when he said it, that this works. We got pretty lucky on our very first try. I hope you're not lost. Understand something. Are we checking 7x times x? No, we put it there. We know what it equals. And are we checking 10 times negative 7? No, we know what it is. We were in charge of that. What we check is the part that we're not in control of. Mr. Purple, you take this out of this lesson, take 3 things out of this lesson, take this. It's all about Mr. Purple and Mr. Green. Can I make them play together to equal the middle? What does Mr. Purple make? What does Mr. Green make? And what's 10 minus 49? Jackpot. Got it on the first try. If you find yourself on some of the problems today and tomorrow needing 5 or 6 or 8 tries, you're not dumb. There's nothing wrong with you. It's totally normal. You'll get quicker and quicker as your senses start to kick in. Right? What made that problem nice and what will make this next problem nice is that the number in front, while it is there and it is a pain in the butt, it is what we call a prime number, meaning there's only one way to multiply to make it. So when I break out my shells, I don't need multiple considerations. That'll be the final set of problems that we do here today. But there's only one way to make it 2 times 1. So that's nice. What does the number in the back tell me? Different. Again, plus, minus, minus, plus, you do you. You just might have to switch them. I might have to switch them. Who knows? Doesn't matter. And this is actually a pretty easy problem because there's only one way to make a 3. So the question now is it 1, then 3? Or is it 3, then 1? Why would it be silly for me to try this? Come on, think about it. Well, just think about Mr. Green. What's Mr. Green? -6. And you're getting yourself too far away from your goal of +1 without any hopes of getting back. So you start to understand that there are sensible places to put numbers. It's still a little bit of a guessing game, but you start to rule out things like putting the 3 dead across from the 2. You want to neuter that 3 by putting it someplace where it's weaker, like that. Let's see if this works. What's Mr. Purple make? Yeah. What's Mr. Green make? What's 3 plus -2? +1. Jackpot. Okay. Now, finally, where this gets a little bit tougher is this is the final push, and then finally I'll be done and you can have some work time, not a lot. Is this. These are the hardest. If you struggle with these, it is perfectly normal. I will do my level best here to just show you the best system possible. And why does this suck? Because 4 is not a prime number. Good listening there, Brendel. 4 is not a prime. You might say, well, why do I care? Here's why I care. If Addie just grabs her piece of paper and goes, okay, those are my shells. It's not true. Because there's another possibility. And so Addie could sit here and try all the numbers that multiply to make 50. 1, 50, 51, 2, 25, 25, 2, 5, 10, 10, 5. And she's like, I don't get it. Miss Raher and I tried everything and it doesn't work. And that might be because there's another template that works as well. Remember that 4 is not prime, so you can multiply to make it 2 or 3 or multiple ways, right? And that's always going to make these problems suck a little bit. So I generally, when I'm talking to a whole class, just so we can communicate, I'll refer to them as like template A and template B. Just so when you tell me what you want to try, you can tell me which template, which pair. One more thing before we begin, let's look at the number in the back. What does he tell me? One of each. So let's try a plus and a minus, plus and a minus. And again, just if we have to switch them later, boo-boo. I would. The thing is, we might find it early, and then it's funny because you might wind up never needing the second template. But so if you wanted to just put one template and then only put the second when you need it, I really don't care. I just put them all. I don't care. All right, let's get into it. What multiplies to make 50? 5 and 10 are probably your first shot. So what do you want to try first? Template A or template B? And which order do you want the numbers in? Template B? 5-10 or 10-5? All right, I'll just take over since you're not saying there. I'll just pick. Who cares? This is YOLO. You just throw caution to the wind. Being a good factor is just making a mess. You just get in, sit around, stare at it. Just try it. So we're going to try Mr. Purple and Mr. Green, and we're going to figure out real quickly that that was a fail. Totally normal, right? Mr. Purple makes 10x. Mr. Green makes -20. 10 minus 20 is -10. So that's a fail. But the good news is every time you fail, you're one closer to getting it right. And obviously switching them in the bottom template doesn't matter because the twos are the same. So the bottom, you don't have to do the old switcher. You want to try 5 and 10 in the top template? Yeah, sure. Let's head north and try 5 and 10. And again, I just keep reiterating, I hope that you're getting the memo. It's all about purple and green. What's purple make? 5x, positive 5x. And what's green make? What's 5 minus 40? We got it. So there's our winner right there. Okay. Factoring can get very difficult if the number in front is like a 12 and the number in the back is like a 48. That's just mean. Because then your 12 in the front can be broken 3 different ways and your 48 can be made a boatload of ways. So we're not going to see anything really nasty like that. Let's do one more and then it's work time. I've got a couple more, but I feel like you're good. Again, we recognize right away that this is a poopy. Go ahead and call it that if you want to, or call it something dirtier if you want. Just, I probably don't want to hear it, but it's a pooper. It's a poopy. And the reason is because the number in the front can be made more than one way. So when I build my templates, this is a possibility. So too, though, is this a possibility. And anytime there's more than one, bummer. So we got top template, bottom template. Tell me about the signs there, Addie. Good job, Addie. Did you have a question? Yeah. Can we do like 3 brackets? It can happen, yes. So like if this number right here, this 9 were a 12, then you'd have to do like 12, like 12y, 1y, 6y, 2y, 4y, 3y. That can happen, yes. Good question. I was just answering a question. Just ignore that. I'm going to erase all of that. Okay, that had nothing to do with this actual. So are we ready to roll in? We all agree with Addie that they're both minuses? All right, what comes to mind when you think of 16? 8 and 2. Which template would you like to try? Template A, 8 and 2 like this? I'll take it. Okay, multiply the middles. What do you get? -8, multiply the outers. -18. -8 and -18 make -26. So that's a miss. Okay. But again, just one closer to getting there. So good effort. What else would you like to try? Okay, so you want to put a 2 here and an 8 here. Is that okay? And remember that it won't matter if you go 2 and 8 or 8 and 2 because the 3s keep it symmetric. So let's see if Addie's prognostication is correct. What's Mr. Purple make? What's Mr. Green make? What's -6 and -24 added together? Jackpot. Boom indeed. So that is the fine art of factoring trinomials. I realize that we don't have a lot of time, but your assignment is on Delta Math. It's a lot of problems. there's I really didn't anticipate that we'd have so little time, but why don't you use these 6.5 minutes and see, let's see who can get the furthest. It'll be like a contest in class. See if anyone can get like 8 of them done. It's in Delta, can't miss it. You know the drill. Something like this. This is just a big glorified. Oh, if you guys get something like this is just a big glorified difference of two squares. So what we recognize right away is that, yeah, it's scary, but at the end of the day, it's one of those ones where the middle has to cancel out, right? So when you build these, what you recognize is that you know that one of them has a plus and one of them has a minus, right? And then you say to yourself, I need to have the same thing here and here. Like the yellows have to be the same, and I need the same thing here and here. The reds have to be the same. So what has to go in the yellow spot? What's the square root of all that? 12x. So I need a 12x and a 12x. And then what's the square root of 121? There's your answer. Done. It's a really scary looking problem, but once you recognize it as one of these difference of two squares problems, it's actually super easy. Square root plus square root minus square root.